Hey everyone, Chang here and welcome to my channel. Now, as we start getting to more and more complex topics, we start to see why some people are afraid of math. And when I first studied math, of course, I was deadly afraid of it as well. Because here's the thing, there seems to be a lot of different, I guess you could say, concepts that all of a sudden we're learning. It seems like some of them are disjointed, some of them rely on the other, and then we're not sure how they're related. It just gets mind-boggling confusing, right? So here's the thing with math. Keep in mind that yes, certain concept builds on other concept. That is a given, that is a fact, can't deny that. But other than that, a lot of the stuff that you're learning about math are tools. You be creative, you try to figure out ways how you can apply certain things, how you can reuse, redirect, change certain things to basically meet your agenda. So, for example, we're going to talk about graphing polynomials. Not how you say it, specific or very precise graphing, but being able to guess the graphs of polynomial. So I have one right here. Usually when you encounter polynomials, and especially if they want you to graph it or at least understand how the graph looks like, you have two possible situations. One, they give you just the polynomial. And then basically you're screwed. No, you use some of the tools that you know and you try to get as much information as possible. Of course, there's the other one where you cross your finger and you hope they give you a little more information. So let's look at this really quickly and this. Well, as you can see, there's the equal sign. This polynomial right here is equal to this one. Now, when we're trying to graph or understand the graph of polynomials, there are actually two, maybe three things, right, that we really need to know. First and foremost, now, normally we hear even or odd and we're just thinking about numbers. Even as numbers that could be divided by 2, odd numbers that cannot be divided by 2 is usually how we remember it, right? But when we're talking about graphs, whether they're even or odd, we're actually looking at the largest exponent. The largest exponent actually follows very similar to the idea of even and odd. If the largest exponent is an even number, then your function is usually considered an even function. Not always, but usually considered an even function. And if it's odd, then it's usually considered an odd function. There's actually technical definitions of even and odd. For a function to be even, basically, if you plug in all negative numbers and all positive numbers, guess what? The answer, the end result, the output, still the same, right? For odd, it means that if you put in the positive numbers into the function, it'll produce something. And if you put in the negative version of that number, it should produce the negative version of that output, right? That's what even and odd is. But at least for this sake, in terms of just simplicity, and we're just dealing with only polynomials, just remember that when we're looking at the largest exponents, even or odd, it tells us a lot. The second thing that we actually have to look at is the coefficient in front of the largest exponent. So let's see, how can I word this? The coefficient in front of largest exponent. Now, when I talk about the coefficient itself, I'm not talking about necessarily the number in front, but we just want to know, is it positive or negative? Because if it's positive or negative, it actually tells us a completely different behavior of the graph itself. Now, how do these two help? If it's an even function, here's what you know. The end result of the function is going to have two situations, left and right, where it's either going all the way up, or if the coefficient is negative, it's going to go all the way down, right? So this is the regular positive even function polynomials, basically. And if it's a negative, this two side will end up just going down. Now, this is for even. If it is odd, what's going to happen is that if the coefficient is positive, which is usually what we consider the normal one side, usually the right-hand side, is going to be going up, the left-hand side is going to be going down. It behaves some weird way in the middle, which I'm going to go into details on how to figure out, but mainly at the end, it's going to go up and it's going to go down, whereas in even it goes all up or all down. So this is odd. So you can guess, if the coefficient is negative, then that means this flips, right? And I'm going to use red just to show you. this would end up being what happened if it's negative. This is what happens when it's negative. So those are the two information. Now I mentioned that it's 2-ish 3 because guess what? The third one, which is one we actually really hope they give us, if not, at least have a way of finding out, it's basically the zeros, right? And I'm just going to put a star right here. The zeros of the polynomial. Now what that means is that basically when you factor it all out, you know exactly which number you plug into the polynomial and then the end result would be 0. There's a reason for that. Once we figure out the 0, right, we know at least a little bit more on how the graph behaves. So with this, I'm going to erase all this and then we're going to try to guess what this graph looks like. All right, so with this graph, I'm just going to look at this side, then I'm going to talk about the significance of this side. All right, we're looking at this. We see that the exponent, the largest one, is 3. So we know that this is going to be an odd function. Okay, cool. We see that the coefficient in front of it is a 1. And luckily, it doesn't matter what number it is. We know that it is positive. So hopefully you guys remember. That means however this graph behaves in the middle, we know that at the end, on the right hand side is going to go up, on the left hand side it's going to go down, right? And then however it behaves in the middle, well, we'll figure that out. Now, if this is all we got and we have absolutely no way of figuring out the zeros, then that's kind of all we really know about the graph, right? We can sort of guess, plug in numbers, and then try to figure it out. There's lots of different ways, right? There's ways to try to figure out one of the factors using eventually long division, synthetic division, and so on and so forth to figure out the rest of the 0 and then go that way, right? There's always the idea of I'm going to plug in numbers that I think fits and then guess roughly how it behaves. But overall, like I said, there's lots of different ways to try to figure this out, right? But let's look at this. If we only have this and we don't go any further, this is all we know. But if it gives us more information like this, and this is the pinnacle of what we really want, then we're really good to go. Because guess what? If we look at this, we know exactly what numbers to plug into this polynomial that will give us 0. Remember, since this is 3 numbers multiplied together, technically, right? 3 parentheses multiplied together. If any one of them becomes 0, the end result of this polynomial is 0. That's why these are called the zeros, right? So what number would make this here 0? Well, since this is a plus 2, what would make it 0 is just -2. So -2 plus 2 would be 0. That's one of the numbers. The other one, x minus 2, well, guess what? This must be 2, right? 2 minus 2 is 0. And the last one, what would make this 0? Well, x minus 3, so that means it must be 3. Now, that gives us plenty of information because guess what? Here, if we look at, well, this is 1, 2. All right, that's one of the points we're going to worry about. And then 3 is another point we're going to worry about. And then this one's -2, so it's 1, 2 on this side, and that's a negative. Okay, cool. So these 3 points, the reason I put points here is because we know that's when the graph becomes 0. Now we can sort of see a bigger picture of what this graph is going to look like. And then at this point, we can sort of guess. Let's look at it this way. All right, well, at -2, if we're talking about, like, let's just pick a number on this side. Let's just say -3, because this is a whole number, easier. And if we look at this, we don't actually have to compute the exact value, but we can see that if, this is an if, right? We're looking at potential of -3. If we put in -3, what happens? This is a negative number. This is a negative number, right? And then this is a negative number. So all of a sudden you have 3 negative numbers multiplying together. So it's going to negative times negative, which ends up being positive, and negative again. So we know, and I'm going to use the red one right here, that the graph is always going to be in the negative round, however it goes down afterwards, right? And then from this side on, well, I mean, a good number to pick is probably right here, right? Or 0. 0 is even easier. Let's just pick 0. So we put 0, what happens? This becomes plus, this becomes minus, this becomes minus, right? So it's going to be a positive number times a negative times a negative. Well, the 2 negative multiply together become positive, so it's positive, positive. So that means in this area of the graph, it somehow is going to be positive, so it's behaving up here. But we know that it's going to have to go back to 0, so it's probably looking something like that. And of course, you know, this drawing is not that great, but at least we're trying to figure out the behavior of the graph. All right, well, here we are. Now we know this part is negative, this part is positive. We can sort of guess that it's probably going to go down here, come back up here, and then go straight up afterwards because we need it to always go up afterwards. But just to double check, let's look at this. This is 2, this is 3. Let's look at something in the middle like 2.5. All right, 2.5, if we look at 2.5 and we add them together, well, this is going to be positive. This is going to be positive. This is going to be negative. So positive, positive, negative. These two multiply, positive. Multiply negative is negative. So our guess is sort of correct, right? So it ends up going down here, but then it has to hit that 0 back because we know that's when it hits 0. And then afterwards, if you really want to, you can check, but we know that basically at this point, the graph looks like that. So, I mean, this is an ugly rendition, but basically in the end, this graph is going to look something along the lines of like a weird little S shape. Like that, okay? And see, notice that with the zeros, we know more information. Without the 0, we just know this, and then we have to put in extra effort using all the tools we know to get more information and then start, you know, filling in the blank, basically. Now, as you can see, the polynomial is going to get more and more complicated. And when you experience it in real life, in class, in tests, it'll probably be more complicated than this. But hopefully with the guideline I presented you, that understanding at least the behavior of it is a little easier. So let's look at this really quickly. Ignoring this for now, if we're just looking straightly at this, and which is not really pretty, right? It's not really fun to look at, but I mean, we'll make do with what we can. First and foremost, largest exponent right there. Okay, that's to the 4th power, meaning that is most likely an even function. Now, normally when we're looking at even function, we know that in both ends it should be going up. But when we look in front, the coefficient in front, technically it's a negative. So instead of it going up, it's actually going down, right? So it's an even function, but then both sides most likely going down. Now, other than that, there's really not much we can guess from there. So it's going to be down here on the left, down here on the right. Something like this. That's all we know. Okay? Now, what can we do? Well, we can use, once again, synthetic division, long division, you know, finding factors and then figuring it out and hopefully in the end get to this point, or if, you know, whoever created the problem is really nice, give you this point, and then we can get so much more details, right? So this polynomial right here, if you factored everything out, we get this guy right here, right? It's a negative sign on the outside just to make it a little easier. Then we have x minus 1, x plus 2, x minus 3, x plus 4. So this gives us so much more information. Once again, these are all the zeros. So all we have to do is figure out what would make this 0, what would make this 0, and then again and again. And we have 4 numbers, right? So very simple. X minus 1, what would make this 0? Well, if x is 1. X plus 2, what would make this 0? Well, negative 2. What would make this one 0? 3. What would make x plus 4 0? This is going to be negative 4. So there is our 4 numbers, basically our 4 zeros. So in this case, here we go. Well, let's look at this. We know that at 1, that's one of the zeros. And then at 3 is another 0. We can see that at negative 2, which is going to be right here, that's 1 0, and at negative 4 is another 0. Okay, cool. Now, from experience, you can sort of guess what it is. If not, entirely fine, right? When you first look at it, there's no way anyone without experience will know what this looks like exactly. All right. But we know that this one's going to always go down here. This is always going to go down here. It's going to have to hit 0 eventually. So at least we know the behavior is that this guy is going to have to hit 0 somehow. Now, most likely in this case, it's going to have to go here and then come back and then like that, like a little W kind of thing. But we don't know for certain. We also know that this guy has to hit there. Okay. All right. Now, what else? Well, we can start testing things out, right? So this is a negative 4. This is a negative 2, so we're going to test out negative 3. If that's the case, once again, we don't have to figure out the entire multiplication. We just need to know the behavior. Is it going to be a positive number? Is it going to be a negative number? Well, if it's negative 3, this is going to be what? Negative. This is going to be negative. This is going to be negative. This is going to be positive. And then so if we multiply all of these guys, well, this one's positive, positive, negative. It's negative, right? No, because once again, this is the tricky part. If we put the negative sign out there, we got to remember there's a negative sign. So it's going to be negative times negative, which is positive. These two times each other is going to be positive. So it's going to be positive, positive, positive. So actually it is a positive number. And luckily that was sort of what we guessed. It looks probably something like that. Okay. And then afterwards, now we got to test around here. Now, if it's around here in between these two with the behavior, and zero's there, come on, just do 0. It's so much easier. So in this case, we'll just plug in 0. Well, if this is 0, this is going to be what? Negative, positive, positive. Oh, sorry, that's negative. This is negative, and this is positive. I was looking at the wrong one. All right, so negative, positive, negative, positive. And of course, there's also that negative there. So this is going to be these two multiplies, positive times positive, positive times a negative is negative. Negative times positive is still negative. So that makes sense. So it's most likely going to look something like that. Okay. All right. Well, and then we can continue to check. This is 2, right? Because this is 1 and 3. Remember, from this 1 and 3, and we can check. And hopefully, if we're correct, it's going to be positive, and it's going to look like that little M or the upside down W kind of shape. 2. This one is positive, positive, negative, positive. Okay, so these are positive, positive. All right, cool. Negative times negative is still positive. So in the end, this is still positive. So that's what it looks like. It basically looks like an M or an upside down W. Okay, something like that. All right, so the next one we have right here is even scarier. It's x to the 5th power now at this point. Now this is going to be a even more complicated looking graph, right? But luckily for us, there are some patterns. But here's the thing. I wanted this particular problem because when I was teaching and when I was learning, especially when I was learning, I made a huge blunder. Right? I made an assumption on certain patterns just based on my experience and luck of the draw, the numbers that or at least the polynomials I've encountered sort of verified, right, my justification, but it ended up not being correct. The idea is this. I've seen students, and I myself have made this sort of assumption. If it is to the 1st degree or 1st power, right, it's a line, x to the 1 power. It's usually a line in some way. And all of a sudden, when we look at it, parabola is usually to the 2nd power, right? X squared, so on and so forth. Cube looks like that, which from our experience in the previous problem, that's kind of what it looks like. And then we have the 4th one, which looks like that, right? And then eventually, as you guys gain more experience, all of a sudden you're going to see the 5th one looks probably something like that, and so on and so forth. But that's not the case. Never make this generalized assumption. I mean, maybe you'll be a little safe with this one and this one to a degree, but past that point, you have to be very careful because there are certain problems, right, that even though they're to the 4th power might look like that. Even though they're to the 5th power might look like that, right? We can't make that assumption. We have to find the zeros and test the behavior between the zeros to figure out what exactly it looks like. If not, just be very careful of that. So I'm going to erase all this and we're going to go over this problem because guess what? If I talked about all this problem is not going to behave like that. It's going to look like something else. And so here's the thing. To make it a little easier, this is x plus 1 to the 5th power. Notice that there's 5 0, but they're all exactly the same. So let's go into detail of what this one looks like. All right, so here we are. Everything's erased, everything's good. We have, once again, our 5th power. So we know that this is an odd function, an odd polynomial. And we also know that in front of it, there's no negative sign. So this is actually positive, which is good. And then, of course, afterwards, we know the zeros, which I've given right here. Now, with these two, we just know that, all right, right-hand side, left-hand side. That's all we know. And then we go with our special skills and everything, and then we start finding out more information, and voila, this is what we have. So what does that mean? Well, there are 5 zeros technically, but they're all the same number because guess what? It's basically x plus 1 times itself 5 times. What would make this 0? -1. That is it, right? So in this case, it would be right here, -1. Okay, and all you can really do is test what happens if the number is on this side and what happens if the number is on this side. Notice that there's really no other zero, there's no other points. Maybe there's some behavior here and there, but mainly, let's see. Well, if this is -1, if we put -2, well, you know, that's negative. So basically the behavior of this is gonna look like that. Okay, well this one, there's a 0 right here, and of course you could pick any number to this side and test it out, but basically past 0 at this point, they're all positive, so it's gonna look like that. Okay, and so that's basically what this looks like. So basically, it looks almost, maybe not necessarily exactly, but almost like a cubic function instead of what we would assume. It would squiggle more and more, right? The squiggling only comes because you have a lot more zeros, and there of course are those special cases of polynomials or functions in general that actually might squiggle on top or squiggle on bottom. Those are just specially created, and whoever gave it to you is kind of a jerk for that. But other than that, this is what this looks like. So hopefully with this, it actually shatters that potential misunderstanding that, oh, okay, if it's more complicated, just add a little more squiggle. Not necessarily the case. You really have to see the problem. You really have to figure out more information before we can even guess the behavior of the middle structure. Remember, if we only have this, we either have here, even or odd, in front, positive or negative, and then we just have to find more information. All right, so we reached the end of the video, and what exactly was I hoping that you would get out of it? It's quite simple. We're guessing polynomials. All we're doing is we're given something, and we're trying to, you could say, conceptualize and see what it would behave like, right? And hopefully with all the different examples, I've shown you potential pitfalls and things to, I guess, keep in mind. Once again, is it positive? Is it negative? That's the coefficient, right? Is it odd? Is it even, right? That's telling you the behavior of, you know, going both sides the same way or both sides different ways. And then afterwards, I hope you realize with this that in math in general, it's almost like a spider web. Everything we're learning is tools. Some are built on each other and will rely on each other heavily. That's great. That's wonderful. Some, not so much. But there's always a potential to finagle it, to use it in a different way that would actually help you. When you look at a polynomial, the only thing you can really think about is maybe simplifying, factoring, and graph. But then afterwards, you realize, for example, long division or synthetic division, right? Understanding, I guess you could say, like terms and common factors will actually help you figure out the zeros a little easier. And even something like a special problem like this, Pascal's triangle, and if you guys don't know what it is, don't worry about it. It's just another different math concept, right? Would help with this as well. So hopefully you guys understand that. That's all math is. A bunch of tools. Some will be useful, some will not be. But the idea is that every time you're approaching a problem, be creative. See what you can use, what you cannot use, and the core is why it works or why it doesn't work, and then you'll be good to go. So hopefully with this, it emphasized a bigger lesson, but at least, if not, remember how to guess the behavior of a polynomial when you see it without having to go into extensive detail, using a graphing calculator, and killing yourself by, you know, plotting every single point just to be absolutely certain this is the behavior of the polynomial. Thank you for watching. See you in the next video.